Okay, then coming to the next concept that is called study of DC transient in a series RC circuit. That one numerical problem. Okay, this is one of the example. 10.6 square. 10.6. The switch as shown in figure 10.22 is kept to open for a long time. The switch is open for a long time and then it is closed at t is equal to 0. Find VC of 0 minus, that is called voltage across the capacitor. VC of 0 minus and VC of 0 plus and IC of 0 minus, okay, and IC of 0 plus, and then dVC of t by dt, dVC of t by dt at t is equal to 0 plus, and then sixth one, find the time constant of the circuit before and after switch is closed, and then seventh one, VC of infinity. It's clear. So draw the circuit diagram. So circuit diagram is called 10 ohm resistor. Okay, this is called 40 volts. 40 volts, and this is called capacitor, another terminal. Okay, and this is the switch. This is the switch. Switch is connected like this. At t is equal to 0, switch is closed. This is the meaning of the switch. And here was the resistance here 6 ohm. 6 ohm. The resistance is 6 ohm. So what is the capacitance? C is equal to 4 farads plus and minus. So what is the question? First question here? That's the first question. First VC of 0 minus. VC of 0 minus. So what is the meaning of the switch? What is the meaning of the switch? At t is equal to 0, the switch is closed. Understood? At t is equal to 0, the switch is closed. T is equal to 0, switch is closed. That means at t is equal to 0 minus, t is equal to 0 minus, that is here, at t is equal to 0, switch is closed. At t is equal to 0 minus, switch open, and also t is equal to minus infinity also, switch is open, and t is equal to 0 plus, switch is closed, and t is equal to plus infinity, also the switch is in closed condition. This is called a steady state. Okay. And this is also called steady state. T is equal to minus infinity is also called steady state, and t is equal to plus infinity is also called steady state, and this is called a transient. Okay, transient state. So first VC of 0 minus, that means at t is equal to 0 minus, so what is the switch position? At t is equal to 0, switch is closed, means at t is equal to 0 minus, switch is open. Then only it is possible to close. Understood? At t is equal to 0 minus, switch is under open circuit. So open circuit means at t is equal to 0 minus. So what is the state of the circuit? Is open. T is equal to minus infinity is also, switch is open circuit. Okay. So there is the circuit diagram. under t is equal to 0 minus and also t is equal to minus infinity. So t is equal to 0 minus and t is equal to 0 minus infinity. Switch is open. So this is the capacitor. Switch is under open circuit condition. At t is equal to 0 only, the switch is closed. T is equal to 0 minus, switch is under open circuit condition. Am I right? So here, so what is the resistance? 6 ohm resistor. Connected like this. 6 ohm resistor, switch open. Okay. So what is the resistance here? 10 ohm. Here 40 volts. Plus minus. So plus minus. So what is the voltage across the capacitor? In between VC of 0 minus. So VC of 0 minus is equal to VC of minus infinity also, because of switch is open at t is equal to 0 minus and also t is equal to minus infinity also, switch is open. So under steady state condition, so what is the position of the circuit? Same as at t is equal to 0 minus. Understood? At t is equal to 0 minus, so what is the, so at t is equal to 0 minus, what is the position of the switch here? Open. Similar way, t is equal to minus infinity also, this switch is open. That means steady state condition. You know well, under steady state condition, capacitor acting as a open circuit. Okay, capacitor acting as a open circuit, open circuit, open circuit under steady state condition. Okay, under steady state condition, capacitor will be acting as open circuit. Okay, under transient condition, capacitor will be acting as a short circuit. So because of it's not allow the sudden changes in voltage. Okay, transient condition. Transient condition, capacitor is acting as a short circuit. Under steady state condition, capacitor acting as an open circuit. So under open circuit condition, so what is the voltage here? Okay, under open circuit condition, what is the current flowing through 10 ohm resistor? What is the current flowing to the 10 ohm resistor? So 0 now. So because of, so they like this circuit is like this again, 40 plus minus. Under steady state condition, capacitor will be acting as an open circuit. Okay. So this circuit state under t is equal to minus infinity or t is equal to 0 minus, acting as an open circuit. That is in mathematics VC of 0 minus. So 10 ohm. So what is the current here? Okay, IC of 0 minus. That is means IC of 0 minus. Current flow into the capacitor under t is equal to 0 minus. So what is the current flowing into the capacitor in this case? 0 minus, no? 0 minus is equal to 0. The current flowing into the 10 ohm resistor, 0. No current flowing to the capacitor. That's why IC of 0 minus is equal to 0. So that's why the current voltage drop across the 10 ohm resistor is 0. Voltage drop across the 10 ohm resistor is equal to 0. No? That's why there is no voltage drop. That's why, so what is the voltage here? Supply voltage. Same voltage across the capacitor. That's why VC of 0 minus is equal to the 40 volts. Understood? So this is the voltage across the capacitor, VC of 0 minus. And then what is the current flowing through the capacitor at t is equal to 0 minus? That is called IC of 0 minus is also 0. 0 amps. The current flowing through the capacitor under t is equal to 0 minus. So is equal to 0 because of capacitor acting as an open circuit. It's clear. Then, so what is the second one? First one is over, and the second one now. Vc of 0 plus. Vc of 0 plus. Okay. So at t is equal to 0 plus. So what is the position of the switch? At t is equal to 0, switch is closed. At t is equal to 0 plus also, switch is closed. No? At t is equal to 0, switch is closed. Understood? At t is equal to 0, switch is closed. At t is equal to 0 plus also, switch is closed. Okay. So this circuit will be so like this. 10 ohm resistor, 40 voltage source. Okay. And your circuit is switch is closed. No? Switch is closed. So like this. And what is the resistance here? So resistance 6 ohms. Switch is closed. Okay. So then what is the resistance here? 10 ohm. Here 40 volts. So first we have to know. So at t is equal to 0 plus, that is called under transient condition. Okay. How the capacitor will be acting? How the capacitor reacts? Okay, under transient condition. If initial conditions are exist, so initial conditions are exist, it will be acting as a source. It does not allow the sudden changes in voltage. Okay. So capacitor will be acting as a short circuited. Capacitor will be acting as a short circuit. Understood? Capacitor is acting as a short circuit at t is equal to 0 plus. Okay. At the instant of switching action, capacitor does not allow the sudden changes in voltage. That's why it is acting as short circuit. If any voltages are present in previous case, that's why it acting as a source. Okay, it will be acting as a source. If initial conditions are exist. If initial conditions are exist, it will be acting as a source. So initial conditions are is nothing but so voltage across the capacitor Vc of 0 minus is equal to 40 volts. Na? Initial conditions are exist. That's why it will be acting as a source, but it is acting as a short circuited. Capacitor is acting as a short circuited, but it acting as a source. Plus minus. Okay. So then what is the voltage across the capacitor? So this is the voltage. So this is the how much of voltage? 40 volts. And also capacitor does not allow the sudden changes in voltage. That's why. So at t is equal to 0 minus, what is the voltage appear across the capacitor? Same voltage appear across the capacitor at t is equal to 0 plus, because of it's not allow the sudden changes in voltage. So that's why the voltage across the capacitor here, what is the voltage? Here high potential, here low potential. Okay, that's why here 40 volts. Okay, here capacitor Vc of 0 plus. Okay, that is called voltage. The voltage across the capacitor is nothing but Vc of 0 plus is nothing but 40 volts. Okay, so capacitor connected in between these two terminals. That's why voltage across the capacitor is nothing but so 40 volts. It's clear. Then IC of 0 minus. Then third one IC of 0 minus. Okay, so t is equal to 0. T is equal to 0. Switch is closed. T is equal to 0 minus. Switch open. Okay. At t is equal to minus infinity also open. Switch is open. at t is equal to 0 plus this is called at t is equal to 0. The t is equal to 0 plus closure at t is equal to plus infinity also closure. Understood. At t is equal to 0 minus h is open means t is equal to minus infinity is also open. This is called steady state. Okay. Under steady state condition, switch is acting as a open capacitor will be acting as a open circuit. So this is the circuit. This is the capacitor. Na? Switch is open. Then 6 ohm resistor. This is called capacitor. It's called 10 ohm. So 40 volts. Capacitor under steady state condition. Steady state condition. Capacitor will be acting as a open circuit. Open circuit. That's why. So what is the voltage here? Under open circuit condition, what is the current flowing through the capacitor? That is called IC of 0 minus is equal to 0 amps. It's clear. That is the third one. Then fourth one, IC of 0 plus. IC of 0 plus. At IC of 0 plus, at t is equal to 0 plus, switch is closed. Am I right? So what is the circuit here? Again now. So resistor and there is the capacitor. Okay. So in this case, at the transient condition, capacitors not allow the sudden changes in current, sudden changes in voltage. Capacitor is not allow the sudden changes in voltage. That's why it acting as a short circuited, but it acting as a source. Okay, because of initially some amount of voltage appear across the capacitor. That's why it acting as a short circuit. Okay, but it acting as a voltage source like this. So here 40 volts. Here what is the resistance here? 10 ohm resistor. Here short circuited. What is the voltage across the capacitor VC of 0 minus? So initially some amount of voltage agrees it, that is called 40 volts. And the switch is closed. Am I right? The switch is closed. And here what is the resistance? 6 ohm. This is the circuit under at t is equal to 0 plus. And then what is the voltage here? 40 volts. So what is the voltage here? 40 volts. That's why the current flowing to the 10 ohm resistor is 0. There is a potential difference between these two. Okay, 0. The current here 0 in this circuit. But here, so what is the voltage across this 6 ohm resistor? Parallel. Okay, this is connected across the parallel. Then current flowing through the capacitor is nothing but IC of 0 plus. Then IC of 0 plus is equal to the current is only circulated. So like this, current is circulated in the circuit like this manner. No current flowing through the 40 ohm 10 ohm resistor because of here 40, here 40. That's why this 0. So the only current circulating in this direction, and that current is nothing but IC of 0 is equal to IC of 0 is equal to. So what is the voltage here? 40. So 40 divided by 6. Okay, that is the current flowing through the capacitor. So that is 6.66 amps. Okay, this is the current flowing with the capacitor after t is equal to 0 plus. Then fifth one, so dvc of t by dt at t is equal to 0 plus. You know, I is equal to capacitor, current flowing with the capacitor IC is equal to C into dvc of d by d. Okay, at t is equal to 0 plus. So it will be like IC of 0 plus is equal to C into dvc of 0 plus by dt. Then dvc of 0 plus by dt is equal to IC of 0 plus by IC of 0 plus by C. You know, IC of 0 plus is nothing but 6.66 by C. C how much? 4 farads. Okay, that is equal to, so 1.665 by volts per second. This is called dvc of d by dt. It's clear. Next, time constant of the circuit before switching action. Okay, time constant of the circuit before switching action. Before switching action, the circuit will be like this. Switch is open. So what is the here? 40 volts. So 10 ohms. Here 4 farads. So time constant of the circuit before switching action, that is called time is equal to RC. Yeah, 6 ohm resistor is not connected into the circuit. That's why. So what is the time constant? Here R is equal to 10 and T is equal, C is equal to 4. Then that is called 40 seconds. Okay. So by making voltage source short circuit. Okay. Voltage source short circuit, current source open circuit. This is the time constant of the circuit before switching action. Next, time constant of the circuit after switching action. Time constant of the circuit after switching action means this is the circuit. Here 40 volts and your capacitor switch is closed now. That is called 6 ohm resistor. Here 10 ohm resistor is called 4 farads. Then to find the time constant, that is called RC. That is called voltage source short circuit. So then 10 and 6 are parallel. 10 into 6 by 10 plus 6 into RC to C 4 farads. This is the time constant of the circuit after switching action is equal to approximately 15 seconds. Okay, so this is the time constant of the circuit before switching action and time constant of the circuit after switching action. Then finally, Vc of infinity. So Vc of infinity means circuit under open circuit. So under steady state condition, capacitor will be acting as an open circuit. So what is the voltage across the capacitor is nothing but voltage across the resistor is nothing but voltage across the resistor is nothing but voltage across the capacitor. Voltage across the 6 ohm resistor is nothing but voltage across the capacitor. The voltage across the resistor 6 ohm resistor. Voltage across the 6 ohm resistor. Okay, that is equal to Vc of t is equal to, so 40 into voltage division rule, 40 into 10 plus 6 to 6. So that is equal to 15 volts. This is called Vc of infinity. 15 volts. Understood? The voltage across the 6 ohm resistor. This is the circuit. 40 volts. This is called capacitor. This is called switch is closed. 6 ohm resistor. So 10 ohm resistor. So 40 volts. So voltage across the, this is called voltage across the capacitor VC of infinity. So voltage across the resistor is nothing but voltage across the capacitor. So parallel. No? These two are parallel. That's why voltage across the 6 ohm resistor is nothing but voltage across the capacitor 6 ohm. VC of infinity is nothing but 40 into 6 divided by 10 plus 6 into 6. Okay, is equal to 15 volts. That is called voltage across the capacitor. That's it.